Hello and welcome to the AWS Certified Cloud Practitioner session. Today is the second session. This is a 2-week session that will help you get through your AWS Certified Cloud Practitioner exam. This certification is intended for IT folks who are just starting out with AWS, non-IT folks who are getting into AWS, people from the sales, legal, and marketing teams, business analysts, project managers. What do you need to study for this exam? The prerequisites are that you have general IT business knowledge and IT technical knowledge. An introduction about myself: I'm Anant Tirmanur. I have over 16 years of experience. I am a Google Cloud Certified Professional Architect. I do have 3+ years of AWS experience, and October I completed my AWS Cloud Practitioner Exam certification as well. And I have experience working in GCP as well, so I have a good perspective of Google and AWS experience. So for this exam, there are 4 domains that you need to learn, and these are the concepts you'll be tested on. So we'll be covering all these in our 2-week session. The first part of it would be cloud concepts. We started it last session, and we're going to continue and go on with it. As a reminder, please subscribe and like our channel so that we can help out other people who need to get that. For today, as similar to last week, we're going to take the same example where we're building a chat app, and this example will be used to explain all the cloud concepts. We are building a chat app where one person, client 1, can send a message to user 2. The server checks whether the request is perfect, and then whether the person is authenticated to send to the other person, and then sends the message, and then informs user 2 of the message, and also passes the success message back to client 1. So the client sends the message over the server. The server makes sure everything is authenticated and then sends the message over to client 2. And then after everything is successful, the server sends a successful message to client 1. Last time we kept it a little bit simpler, and we simplified the requirements to just have one-on-one text. Now we are expanding it to see more examples. In today's example that we'll cover, like all the cloud concepts, we'll go through this example. So the application that we build will support one-on-one texts. It will also support group chats. You'll be able to upload or send images, videos, files. You should also be able to indicate if somebody's read the message or received the message. It should also indicate like user's last seen time. So if somebody has last seen it on today, last seen it today, 3 hours ago, that should be indicated. So last time we covered 7 concepts. We'll go on to the 8th concept that we were trying to cover. Those are microservices. So what are microservices? Microservices is a software that is composed of small independent services rather than one large monolith. And these independent services communicate with each other, and they communicate to the external network over well-defined APIs. As these services are small and independent, these can be owned by small self-contained teams. The microservices architecture, the major advantage of that is that we can easily scale and it is much faster to develop. Thereby, we can make changes much quicker, so we can innovate much quicker, and we can accelerate the time to market. Any new features that we want to add, we can add it much sooner than in a monolith architecture. So the monolith architectures are right for certain cases, but in a lot of cases, we are trying to build microservices instead of monoliths that we used to build in the earlier versions of software. So most new builds, we're trying to break them down into microservices and build them. It's not that microservices are always right, but in most cases, microservices are the better option compared to the monolith. Here in the left, we're talking about the monolith architectures. So the monolith architecture, if you see, it has one big server which serves, or a set of server farms which serves the user function, the threads, the posts. But when you break them into microservices, like you have separate user service, separate thread service, and separate post service. With monolith architectures, what happens is all these users, threads, and post services are tightly coupled. So they all share the same database, they all share the same servers, they all have the same networking infrastructure. So if there's a spike in demand for, say, number of posts, but the number of users are not increasing, we have to scale the entire architecture. But with microservices, we can actually independently scale them up or down, and say there are too many posts coming in today because it's a weekend, and there's some news that's happening. So that would mean the number of posts increase rapidly. So we have to scale the post server. So we can do that independently. We just scale the post service. So the servers or the containers which actually host the post service, those can be scaled, but you can keep the user service and the thread service the same. So as we said, we build communication mechanism so that they have APIs. APIs are interfaces where services are exposed, and communication can happen. So we'll take an example and see how the microservices will work in our example of chat server. So these are some of the services that we can build independently. This is not a complete list, but just to give you an idea of what microservices we can build. We can build a specific chat push notification service that just notifies people whenever they have a message. We can have a separate chat media storage service, so whenever somebody uploads or sends an image or a file, that gets into the media storage. You can also build a separate chat contact list, so if somebody wants to look at the contact list and contact a new person that's not in the current list, so they can search that up or look it up. So that will be a different contact list service. It's a separate authentication service to make sure you are who you are, and you have authentication to send message to someone. So that there's a separate authentication service, and there can be a separate profile setting service. So if I want to update my profile, my photo, my name, my phone number, those can be separately updated using the profile setting service. Again, as we said earlier, we can actually scale up and scale down just the profile settings. So if there are too many people who are setting up new profiles, if that needs more or less capacity based on what's happening, so that can be done. And each of these, say for example, the contact list can be managed by a smaller team rather than having one huge team that manages the database, the uh, the networking, um, and the servers, and the code base for the chat to happen. Instead of that, we can manage each of these services by smaller teams. Essentially, the biggest advantage of microservices is that it's faster to develop and innovate. The next concept of cloud basics that we're going to cover is loose coupling. So when one element of your application changes or has an issue, it shouldn't bring down the whole application. And this kind of ties in with our previous concept of microservices. Whenever we build a big presentation layer, um, a business layer, and then a database layer, in a monolithic application, if something happens to the database, and the database is locked, or the database is unable to be like there's a server, there's a network issue to reach out the database, then all the users using them for multiple reasons, whether they're going to do an order processing, whether they're going to do an inventory module or the customer module, they're still going to not be able to like get the information they're looking for. The system will be down. Rather, when we separate them into multiple microservices, and those are loosely coupled, that means they're not tightly coupled, they're independent of each other. So in that case, when the database for order processing fails, so people may not be able to add orders or put in orders, but we could still go in and look at the inventory. The customer module would still work. That's the advantage of loose coupling. So in our example, when we built a microservices architecture earlier, we had separate services for all of these. Here, for instance, when one of the component fails, that's the profile settings fail, people would still be able to chat with each other, people would still be able to share media with each other, and they'll still be able to check the contact list, but the profile settings would not work, and when you click on profile settings, it will throw in an error message saying not available at this point, or like another user friendly error message. The next concept we'll cover is disposable resources. Like in-house, like this is one important concept in cloud basics. We when we build an independent uh, in-house server, we always like have to invest in it well ahead, and we cannot actually dispose of the servers or use them for something else when we are done with it. So in an in-house server, the capacity is still left unused. We cannot dispose of them. We cannot sell them off to somebody else or rent them out to somebody else. The capacity that we use uh, is what we use. The unused capacity is just our spare capacity, and we keep it so that in case some spike happens, then we use it. In some cases, when we know that our business has a seasonal demand, for example, if you're a retail store and there is a seasonal demand during the holidays and Thanksgiving, um, so we know that there are a lot more people who are going to shop in your like store on your website during the holidays. So seasonally, the demand for the server capacity is going to be high. But say in the summer, there's not going to be as much demand, but we can't dispose of the resources when it's an in-house server capacity and say that I don't need it for the next 6 to 8 months. I'm just going to need it starting October or November. Um, that is not possible. So we still hold on to the unused capacity. So this is where cloud has a huge advantage, where we can actually use resources and dispose of the resources that we don't need. So I'm going to take 3 different ways where AWS offers this to be done. The EC2 instance is just like renting a server. So in that case, the EC2 instance can be part of a auto-scaling group, and we can create rules about uh, creating and destroying new instances. So whenever there's a spike above a certain limit, so there's 80% server capacity or more, the auto-scaling group can be set up so that it creates more servers, and whenever it goes below like 25%, then we can kill one of the servers and like distribute the new load to the remaining servers. So that can be done using EC2 instances and auto-scaling group. So the ones that we dispose of, those are disposable resources. When we come to serverless functions like Lambda functions always only use resources as you go. So you don't really um, like set up some resources and then use it and let it go unused. The Lambda function, like whenever it gets in upon invocation, it starts a compute unit, and after the invocation is complete, so if somebody calls a service, the compute unit starts, and then after the service is done, if there are no more active services, the compute unit is disposed of. So that is like only used when you go. And the third example where you don't use EC2 instances, you don't use Lambda function, but you use a container. When you use a container, the basic concept is to build a package of all the software that you need together, and that is an immutable application image. So the biggest advantage of that is whether you launch it in any type of server, whether it's a Windows server or Linux server, when you launch it, you have all the required software that the application needs, and it's launched the same way and behaves the same way. So whenever we build multiple copies of the application, a container image is used to build new copies of the application, and whenever the resource needs are lower, we can dispose them off and not use them as needed. Okay, the next an important cloud basics that we're going to cover is high availability. High availability is a term that's used not only in cloud but also in-house. Um, like high availability describes the systems that are dependable enough to operate continuously without failing. So the major thought process behind high availability is that we don't have uh, we don't we don't stop the system because the server is down. We don't stop the like we don't have too many users get a service not available, or they're unable to get on my website, or they're unable to use our service. So we try to ensure most end users are able to access our application all the time. So one of the major ways we achieve this is by having replicated servers, and those are like standby servers that have similar functionality to what our application does, but those are like set up in another locality. We look into what availability zones are in the next slide, but they're placed in a different location in a different server, and they do the same functionality that our server does. And in case our main server breaks down, the replicated server can take over the newer service requests that come in, and those can be serviced by the replicated servers. that's one concept where use high availability. And that concept of high availability is called redundancy. So we have redundant servers, the servers that really don't take up any um, any load at a given point. But when the main server fails, the replicated server or the redundant component takes up the load and picks it up and serves the users. With respect to cloud and with respect to availability zones, um, we cover this because AWS uses the terms availability zones. So we'll get into this a little bit later. Like AWS has multiple regions within the world, and each region is split into multiple availability zones. So this is a huge thing you need to understand for high availability. So whenever an end user goes through and hits a service, um, we could have the service set up in two different availability zones. So the availability zones have are within a region. There are multiple availability zones within a region, and to build fault tolerant and highly available applications, those are used. An availability zone is either one separate data center or more like separate data centers. But what happens is they have redundant power. So if availability zone has power company A and availability zone has power company B, and they are in separate grids, they have separate networking companies. One is served by Verizon, one is served by Comcast, and so they have different connectivity, but they are all so the availability zone here shown A and B would be having replicas of the same web server application that we have, same application server. They'll have a replicated data layer so that the data gets replicated as well. Um, so either it gets updated in zone 1 and then goes on to zone B all the time, or there's a way to replicate it two-way, but somehow the data can be built out to be replicated in both zones. And then based on that, we build fault tolerant, redundant, highly available applications. The next concept we'll cover today is the 6 core perspectives of cloud adoption framework. Um, After this, we'll go into a set of questions that we'll try to answer based on the concepts we learned in the previous session and today's session. But yeah, this is something that AWS lists as 6 core perspectives for cloud adoption. What this is if your company is currently already having its infrastructure on this on-prem, and we want to adopt into cloud or move into cloud, there are multiple perspectives. So business would have a perspective, people would have perspective, governance. Based on the governance perspective, we might want to move into cloud. Based on the platform perspective, based on the platform in the cloud being much better than the platform that we have, we might have another perspective to move into cloud adoption. Security will be another perspective. We'll consider what security that the cloud has versus what security the on-prem has, and how much of effort you need to put into security when it's on-prem versus security on the cloud, because some of the aspects of the hardware security go away on the cloud infrastructure. We also, the last perspective is the operations perspective. This focuses on operating and recovering IT workloads to meet the requirements of your business stakeholders. Essentially, I'll just go over them again. So the business perspective, um, in most current projects, like business has their own strategy and IT has their own strategy. The business perspective of AWS helps to move from that model of having separate business and IT strategies into one model that integrates the IT strategy into your business model. So at the end of the day, all the IT work that businesses do is for their business model to like scale up or do better. So this way, when we integrate the IT and the business strategies, it helps that business perspective. With respect to people perspective, it helps the human resource employees, the HR employees, prepare their teams for a cloud adoption by adopting organizational processes and staff skills to include cloud-based competencies. So in this one, what happens is we talk to the HR staff so that they can set up trainings and make sure they understand the cloud-based competencies and add them to their learning platforms and add them as goals for people to learn so that HR can enable the cloud adoption. Governance perspective comes into place where when we align IT strategy with business strategy, um, there are some processes that need to be done so that these processes that we put in would help us govern, and it also ensures that you maximize your business value while you minimize the risks. So the governance perspective is essentially a set of processes that we put in so that the IT strategy and the business strategy align. The platform perspective talks about how you design, implement, and optimize your infrastructure based on your business goals. So in this case, we don't build the software independently, but we try to design it, implement it, and optimize it for what the business actually needs and what the business goals are. The next one is the security perspective. So like this ensures that the organization gets all the security objectives met, uh, not only for auditability, control, agility, and visibility. The last perspective, the operations perspective, focuses on operating and recovering IT workloads to meet the requirements of your business stakeholders. Let's look at a question based on this. Which perspective of the AWS Cloud Adoption Framework helps you design, implement, and optimize your AWS infrastructure based on your business goals and perspective? So here we could easily get confused because it talks about the business goals and perspective, uh, but they're asking the question essentially asks like how do you design, implement, and optimize your infrastructure based on the business goals? So if you remember, we were talking about the platform perspective where we want to have the most optimized um, infrastructure based on the business goals and perspective. So I think we should um, choose the platform perspective. And to remind ourselves, the business perspective helps move from a model that separates business and IT strategies into a model that integrates business model and IT strategy. For the operation perspective, what we had seen earlier is that it focuses on operating and recovering IT workloads to meet the requirements of your business stakeholders. The people perspective helps the HR team prepare all their teams for cloud adoption. Okay, the next question we're going to cover is availability zones. Which cloud architecture design principle is enabled by availability zone? Is it disposable resources instead of fixed servers? If you remember, disposable resources is where we whatever servers or computing capacity we don't need, we dispose of them until we reclaim it back or when we need it, or dispose of them forever. I don't think that's related to availability zones. Removing single points of failure. This is where, like when we build a monolith, or we build one networking point where all your API calls come in, or like there can be one failure. For example, a database goes down or this networking goes down, and that could bring the whole application down. Um, that is that is a concept that we learned earlier about how we remove single points of failure. But that is not something we do with architecture design principles. With availability zones. So I'm going to eliminate that for now. Amazon EC2, yeah, Amazon EC2 is a server, virtual server, but I'm not sure that's a design principle, and I don't think it's like it has to do with availability zone. So you can set up an EC2 instance in one availability zone and another one in another availability zone for having high availability, but Amazon EC2 itself is not a design principle, and it is not enabled by availability zones. Loose coupling, this probably seems the closest, and I think if we remember when we looked at availability zones, we spoke about how we can have a replica server in another availability zone, um, and we can have okay, let me come back here. So I think um, loose coupling, I eliminated disposable resources. I eliminated removing single points of failure, which I probably think I should not have eliminated. Amazon EC2 instance is definitely not a design principle. Loose coupling is. So 1, 2, and 4 are design principles, but to choose which one it is, loose coupling, to explain that, that's where we have um, like we have multiple services, and we are able to scale up one service, like which is independent of the other service, or scale down the independent services. So having independent services, what uh, this service is, I think it rather helps in removing single points of failure. So I'll revisit my second option, and I think that's the choice I would go with. The next question we'll cover today is, which of the following are key attributes of cloud computing? Um, is it going to be on-demand resources, upfront licensing, global infrastructure, Linux only, API-driven, pay-as-you-go, increased experimentation, lock-in commitments? So this is a very important cloud basics question that like kind of would be twisted a little bit and asked. But I think one of these kind of questions where they ask about the key attributes or the key benefits is definitely going to be there on your exam. So the way I go about this is, probably we can look at certain things and eliminate certain things. Cloud is typically pay as you go, so you this does make sense, but we don't really lock-in commitments unless we pay in for a year, um, like or 3, and we save some money. But that is more of an exception than it is not. We definitely are able to do increased experimentation, but that's not a key attribute of the cloud computing itself. But it's definitely a benefit of cloud computing. You're able to experiment more. So I'm going to eliminate 4, and I'm going to focus on the 1, 2, and 3. Um, let's look at 2 because I see it says Linux only and it says global infrastructure. Given we can do Mac now in AWS, we can do Windows, multiple versions of Linux. I don't think it's right to say Linux only. Even though global infrastructure sounds right, Linux only is definitely not right. So I'm going to eliminate 2 as well. So it's gonna be between 1 and 3. Um, On-demand resources, upfront licensing. Yeah, we definitely get on-demand resources on the cloud. Do we pay for upfront licensing? It depends on the software, but I don't think it's a um, cloud related attribute. Any software that you license and you implement, whether you install it on your cloud or on your own server or on your own laptop, you'll probably have to pay licensing fees. Some of them are pay as you go. Every month you pay it. For example, Microsoft Office, you can either upfront pay or you can pay it uh, every month. Um, but that's not really anything to do with cloud computing. So I'm going to say, even though on-demand resources sounds really good, it's probably not that. Um, I would rather say it's API driven and pay as you go, because all services that AWS offers are API driven, and we could call them through APIs. We could call them through the command line, and you always pay as you go. There are a few exceptions where you can lock in some savings when you do it, but typically the biggest advantage of or a key attribute of cloud computing would be pay as you go. So I'm going to choose 3 and hope that's right. It is. Okay, let's go on to the next one. This one is when designing an application for high availability, it's recommended to use multiple regions, edge locations, availability zones, and Amazon VPCs. Okay, so edge locations are those. So first thing, the question is asking about an application that you're designing and you need high availability. So as we recall, if we need high availability, we try to build a redundant system where we have we have the services built, or we replicate the whole system, including the web servers, the application servers, the databases, on another availability zone or a region, um, and after and we have a way where we can route or reroute it whenever there's an error, or whenever there are it's unreachable, or there's certain types of error where the server is down, or the application is down. We'll be able to reroute it to another redundant location in another availability zone. Um, so in that sense, I'm going to choose between 2 and 3 and then think about them. I'm going to talk about what edge locations are. So edge locations are where um, uh, we have a cached version of our data or website or any static information, so that people around the world can quickly get to our data. So that is not really high availability. It's more of um, Netflix having their version of um, Squid Game latest season available in all edge locations around the world. So people in Australia can still see it, can stream it at a really fast pace. while people in California can stream it at a fast pace as well. So those are edge locations. Those are more of how the requests are cached, and how the data is cached, and how the requests are retrieved from a location closer to the user location than from the actual servers. So I'm going to say no to edge locations, and I said no to Amazon VPCs, and my reasoning is VPCs are virtual private clouds. I think we haven't touched that yet, but more so when we learn about it. This is where we cut off access into our own private cloud. So any request that comes into the virtual private cloud would need to be authenticated, or would come in through some gateway, and that would need authentication. So this is where a corporate or a team within a corporate has its own VPC, and within that VPC, only the communication can happen to the external world, or from external world to the VPC, only through certain gateways that allow communication to it. So yeah, that's a concept we'll definitely cover in our future sessions. Now, to talk about regions and availability zones, we can set up high availability zones in different regions. So we can set up like the Europe region, and one in one of the North America regions. We can set up two different set of services. We can have a replica for application in both the regions. And if one fails, we can always have the other region take over. But that's not the like intention of regions. The intention of regions is like a Europe service can actually serve Europe or people closer to Europe, um, and the servers in the North America region would serve people in North America, probably South America too, and probably closer to North America than Europe servers. If you have two different regions and we set up the same services in two different regions, it is going to meet your high availability needs, but that's not the region. That's not the real reason to have like services in different regions, because if all your users are from North America, it's going to take much longer for their service to get to Europe and get back. Rather, um, within a region, there are multiple availability zones, and the reason we have these availability zones, which are completely redundant, they have different network providers, different electricity providers, and like it. So those kind of things, it may rather be much more suited for building a high availability application with multiple availability zones. Note, when I was working with one of the major banks in the US, they wanted to have multiple availability zones for high availability and multiple regions. So in case there's a terrorist attack on one country and the whole region goes down, they wanted, or if there's a flood and the whole region is out of power, they wanted a completely another region to be able to take over. So I've seen that they built high availability within a region using multiple availability zones and multiple regions. So yeah, I mean, for this question, because it's an exam question, I think we have to choose availability zones. But in practical life, sometimes we might have to build high availability across regions as well. So there you go. So this was availability zone as the answer. Um, that covers what we wanted to cover for this session. The next session will start up with security and compliance, and that should take um, 1 to 2 sessions as well, and we'll cover those materials. Um, if you have any questions, please let me know in the comments below. Thank you so much for watching. Have a nice day. Bye.